All right, so our third gas law that we're going to cover is Gay-Lussac's law. And this is where the pressure of a gas is directly proportional to its temperature. So we're going to hold the volume constant here, and we're left with the formula P1, pressure of the first gas, over a temperature of the first gas. Again, these need to be in Kelvin for those temperatures, equals the pressure of our second gas over the temperature of our second gas. So again, pressure is directly proportional to its Kelvin temp if we hold that volume constant. So let's go ahead and do a sample problem. This is our third gas law, and then we'll go ahead and combine these in the next video, which will make life really easy for us. I've kind of made things a little bit difficult. This is pretty simple stuff, but we're going to make it really easy here in a second when we combine all these gas laws. So we're going to start with the sample problem. If you want to turn to page 338 in your textbook, we're going to go ahead and work through sample problem 12-3, which is right in the middle of the page there. So again, sample problem 12-3, and that's going to be on page 338 and 339. So I'll do my best to kind of write out those variables if you don't have a book. A few of you don't. So all right, go ahead and follow along with me. The gas is left in the aerosol can, which you can just imagine a hairspray container or a hairspray can, at a pressure of 103 kPa at 25 degrees Celsius. So we have, we're going to start with our initial equation, which is P1 over T1 equals P2 over T2. Gave us the pressure is 103 kPa at 25 degrees Celsius. And it says if you throw this can into the fire, what's the pressure of the gas when its temperature reaches 928 degrees Celsius? So hopefully you've never tried this, but we're going to take that and don't try it. We're going to take that hairspray container, that aerosol can, and throw it into the fire. Let it warm up. You can see this huge temperature difference. We should have a huge increase in pressure because these are directly proportional to each other. So this isn't too bad, excuse me. We just need to convert these to Kelvin and then cross multiply and divide. So to get this to Kelvin, we're going to take 25 plus 273. That'll get us to, 298 Kelvin. So we'll pop 298 right there. And then we'll do the same with this temperature value. Take that 928 degrees Celsius, which is pretty hot, add 273. That temperature is going to be 1201 Kelvin. So let's go ahead and replace that. 1201 Kelvin. And we don't know our pressure of 2. That's what we're solving for. So now let's go ahead and isolate for P2. Do the math however you want. I like to cross multiply and divide. So I'm going to take 103 times 1201. That's going to be equal to 298 times our P2. Divide by 298. Divide by 298. We're left with our pressure of our second gas of the aerosol container. When we throw it in that fire, it's going to increase tremendously. 103 times 1201 divided by 298. Pressure is going to go all the way up to 415 to 3 sig figs kilopascals. Oop. Okay, so very similar to our as far as the algebra goes, just like Charles's law, where we cross multiply and divide to isolate that other variable. So I'll give you 2 practice problems at this point. Hopefully they're going pretty easy for you. We'll combine these in the next video. I'll probably post that today I'm not sure. I'll probably post it today if you want to jump ahead and read it, but that's what we'll probably start with next week. So we'll finish this gas law stuff up next week, have an assessment in the middle of the week, and then we'll move on to a different unit. So today, go ahead and watch this video you already have, and then practice those 2 practice problems that I post today. So have a great Wednesday, guys.